Hello team, greetings for the day. Welcome back to another tutorial on ISTQB. This is Neeraj Kumar Singh and you are watching the tutorial series of ISTQB 2018. Today we are looking at another topic on fundamentals of testing, which is about 7 testing principles. And here we'll be understanding what are those fundamental principles which testing should be following throughout the life cycle and as well as throughout the development model as well. So we have certain good practices, some good protocols to be taken care at any point of time when you deal with testing. So we have got 7 testing principles here to explain you that what exactly each one of them stand for. So we have got 7 principles like testing shows presence of defects, exhaustive testing is impossible, early testing is really important, defect clustering is another concept to be taken care, pesticide paradox, testing is context dependent, and absence of error fallacy. So we will be understanding each one of them in more detail, so just keep on watching the video till the end, which will help you to understand all the 7 principles in more detail. So starting with the very first principle, the first principle name says that testing shows presence of defects but does not prove their absence. Now we understand, being a good tester, that testing is a way by which you find defects. As being an objective of testing, you generally find defects in the application when you test it or in the product when you test it. But no matter how much ever you would have tested so far and whatever number of defects you would have got, whatever number of severe defects you would have got, at any point of time you cannot make a statement that there are no more defects. Because as you go on testing, you may find more defects. So generally, what do you say here is that in case you continue testing, you may find more defects. Then you come back to the same principle that testing shows presence of defect, but at any point of time does not prove that there are no more defects. So generally, we do not guarantee zero defect because we do have different constraints to be taken care in the project, which comes with a timeline and schedule. The next principle is called as exhaustive testing is impossible. Generally, first of all, let's understand what exhaustive testing is. Exhaustive testing means that you try with all permutation and combination of inputs, which would generally lead to a lot of test cases, maybe infinite test cases, which are impractical to be executed. Now, generally, we do not have an end of it, so we call it as infinity, that there is no end to create test cases on any particular thing. You can go on however you want, and everybody's perception is different. Different testers can create a number of test cases on the application, and if you still ask them, you say that, yes, I can go ahead and create number of test cases still. But the problem is we do not have enough time to release a project. So we come with a time frame, we come with a deadline, we come with a time scale where we have to conduct all these activities within that schedule. So generally we say that exhaustive testing is impractical to be conducted within a project. Thus, we state that exhaustive testing is impossible. Early testing saves time and money. Generally, we say that if testers are involved early within the software development model, like not only waiting for the code to be designed and released for testing, we are not talking about dynamic testing any longer. We say that what if you invite the testers right at an early stage when the requirements are being gathered or the design is being prepared. So that generally helps testers to contribute in terms of preparing those work products, which will be helping the other stakeholders to understand the loopholes in the documentation and the work products, which are generally being referred as a test basis for further test case preparation or dynamic testing. So if the defects can be found at an early stage, then it is always considered to be cheaper than fixing it later in the life cycle model. So we always recommend that the testers should be available in the lifecycle model as early as the drafts are available, where they can review the drafts and find out the potential defects in the work products so that the defect is prevented from being introduced into design and code. And of course, that would add a lot of values in terms of success of the project. Defects clustered together, it generally means that the concept of defect density, it's not mandatory that the defects would be always distributed among the modules or evenly distributed among the modules. It is also sometimes possible that the defects would have been gathered at one particular module. So generally say, for example, if you're testing 10 different modules and 1 to 9, you do not get any defects, and you get 50 defects in module 10. And that could be possible because, say, for example, the other 9 modules were so prioritized or so critical that you took extra measures for it. And the 10th one, being a simple module, you took an advantage over that and did 100 mistakes there. So now when we comes to testing, we say that testers must test each and every module irrespective of their previous module execution results. Because if we also build that intention that if the 9 critical modules do not have the defects, then what would the smaller modules or simple modules will have? Then we would lose a lot of defect. So the probability says that it's not always mandatory that the defects will be distributed evenly among the modules. Sometimes it is also possible that all the defects would have accumulated in one module rather than getting distributed. So you need to take care of such things. If you find certain defects in a module, you try to add more test cases to find out the defect density. Beware of pesticide paradox, which generally means that running the same set of test cases again and again would be a waste of time. So say, for example, an instance, you prepared certain test cases and executed it on the application, and the test cases resulted in not finding any defect, like all your test cases passed. Surprised with that, you seeked permission from your manager to re-execute the test because you think, being a good tester, that there are defects in this module. But you want to rerun the same test case to find it. Say, for example, you re-executed it, but still all the test cases passes. Now, of course, we say that in pesticide paradox that it is possible that your test cases are not sufficient enough or efficient enough to find defects. Not mandatorily that your module doesn't have any defect. It is also possible that your test cases, what you have written, are no longer good enough to find any defect in the module. So instead of repeating the same test cases again and again, you may think of revising it or write some new test cases which would help you to find different defects. Because it's also possible that what test cases you have written are outdated or no longer good enough to find any defect. So there's no point rerunning the same test cases again and again just to justify your ego that there might be test cases and my test cases are good enough. So we always look forward to revise or keep updating our test cases from time to time as the requirement gets modified or there are certain updates which takes place in the requirements, and be aware of pesticide paradox. Testing is context dependent. It is another principle in testing where we say that 2 different applications are not tested with same approach, or 2 different projects are not tested with same approach. Just for an example, you do not test an online shopping cart how you test a safety critical system, or vice versa. You do not test a shopping cart like how you tested a safety critical system, or how you tested a safety critical system. You do not put that much effort or that much safety when it comes to an online shopping cart application. Because of course, each type of project, each different project has a different approach required, a different density of test cases required, different type of interaction required. So the effort required is proportional to each type of project. So we generally say that the project approach must be unique for different products and different project being executed. So generally we call this term as test strategy. The test strategy is something which we can call it as approaches. So generally we have 7 standard approaches which we'll talk about it in chapter 5. For that you can stay tuned on the channel for coming to the 5th chapter and understanding more about it. Last but not the least, absence of error is a fallacy. Generally, you may conduct executions, you run different test cases, and you say that you find n number of defects and you fix them. Now, of course, finding and fixing the defect may not be useful if at the end the product is unuseful to the customer or the end user. So what we mean to say here is that no matter how many defects you find, how much effective testing you do, and you fix those defects as well, but if you do not meet the requirements, what it is supposed to be doing, at the end of the day, it is unuseful to the end user or the customer. So meeting the requirement is equally important for the testing team by validating the requirement. So that's the 7 testing principle altogether, team, and I think that was quite clear and understandable to you. In case you still have any further details required for the same, any kind of query, any kind of doubt, feel free to comment below. I'm here to assist you. So till then, keep watching, keep learning, understanding the context. In case you have not subscribed to the channel, please do subscribe to the channel, which will help you to get immediate notifications about my new tutorials on different series as well as this one. So I'll be back with another tutorial on this chapter. We have 2 more topics to go ahead, so stay tuned for that. Till then, take care and thanks for watching the video. Happy learning, team.